Okay, so in our last module for the course, we're going to talk a little bit about solutions and some ideas behind solutions in terms of how solutions are made, things like unsaturated versus saturated solutions. We're going to talk about different types of electrolytes, and then we'll finish up by looking at some terms that are pretty important in the world of solutions, like molarity and dilution. But let's essentially define what solutions are and how we go about making them first. So essentially, your solutions have two components. The first one is what is known as the solvent. And for the most part, solvents are usually liquids. In theory, solvents can be solids, liquids, or gases, but for the most part, your solvents are usually liquids. And we'll see that one of the more common solvents that you come across is water. Now, for a solution, the solvent is usually present, is the component present in a much larger amount as compared to the other component, where the other component of a solution is what is known as the solute. So essentially, when we make a solution, what we do is we dissolve a solute into a solvent. Okay, that's essentially the way that we make up your solutions. Now, the solvent is the component of the solution that's present in larger amount, where the solute is the component of the solution that's present in smaller amount. And your solutes can be solids, liquids, or gases, but for the most part, the types of solutes that you come across are your liquids and your solids. Now, what's interesting is that you could have the same two components for different types of, essentially what are not types of, but essentially what would be known as different concentrations of solutions, where again, one component would still be the solvent and the other component would still be the solute, but the ratio of them would be a lot different. For example, you can make sodium chloride in water solutions, which essentially the diagram on the right is showing you. Salt is, essentially table salt is sodium chloride, and they're talking about dissolving it in water. That's the picture you see to the side over here. There are many different sodium chloride solutions in water. For example, you could have essentially a 1% sodium chloride in water solution, where essentially, you'd have, let's say, 1 gram of sodium chloride dissolved in 100 milliliters of water, so to speak, a 1% solution. You could have a 0.1% solution of sodium chloride in water, where you take the same 1 gram, but this time dissolve it in 1,000 milliliters of water. So essentially, the same solute and solvent combinations can be used to make different solutions. The variable in that case would essentially be concentration. One of the things about solutions is that they are essentially what are known as homogeneous mixtures. Essentially, there's two types of mixtures that you come across. There's homogeneous and heterogeneous. The difference is that in a homogeneous mixture, when you actually look at it, if you didn't see the components being added to it, you can't tell that there are different components that are present. Whereas compared to a heterogeneous mixture, when you look at it, even though you didn't see the actual mixing take place, you could definitely tell that there are two components that are present. So for a solution, when the solute dissolves into the solvent, after that occurs, you really can't tell that there are two or more components that are actually present. And for most solutions, it's two components, the solute and the solvent. Okay. So just to expand on that a little bit, here are some examples of different types of solutions. As I said, the two most common type that you come across are solid in a liquid and liquid in a liquid. But again, there's many other types, gas in a gas, gas in a liquid, solid in a liquid. So really what it just goes to show you is that in theory, your solutes and solvents can be either solids, liquids, or gases. But again, the two most common types of solutions that you really come across are solid, solute, and liquid solvent. and liquid solute in liquid solvent. So how do we tell if a solution is made? When you mix a solute and a solvent together, how do we tell, if a solution is made? Is the solute what is known as soluble in the solvent? What does it mean to be soluble in the solvent? It means that the solute actually dissolves in the solvent. Or is the solute insoluble in the solvent? In other words, it does not dissolve. And in that case, if the solute is insoluble in the solvent, then you're actually not making a solution. So let's consider the two main scenarios that we talked about. Solid solute into liquid solvent, and then in the next slide, we'll talk about liquid solute into liquid solvent. So when you add a solid solute into a liquid solvent, one of two things can happen. After mixing, the solid disappears, or after mixing, the solid remains. If you take a solid solute and put into a liquid solvent and you shake, because usually this is done in a test tube, and if you shake to mix the components, if the solid disappears, then the solute is soluble in the solid. On the other hand, if you add the solid solute into the liquid solvent and all of a sudden you shake and the solid is still there, then essentially the solute would be deemed as being insoluble in the solvent. Now, there are some other mitigating factors in terms of the amount of solute that you use, the amount of solvent that you have, and there's other factors as well. But this is sort of the general idea that we see when we try to make a solution of solid solute into liquid solvent. The solid disappears. We generally say that the solute is soluble in the solvent. If the solid remains after mixing, then we generally say that the solute is insoluble in the solvent. What about a liquid solute into a liquid solvent? This is a little bit trickier. If after mixing, only one layer appears, in other words, that you actually can't tell that two liquids are present. If that's the case, after mixing a liquid solute and a liquid solvent, that means that the liquid solute would be soluble in the solvent. So essentially, you know that you added two different liquids, but after you mix them together and you look inside again, probably that test tube, you can't tell that there are two liquids that are actually present. That essentially means that the liquid solute dissolved into the liquid solvent. On the other hand, if you mix the liquid solute into the liquid solvent, and after shaking for mixing, you still see that there are two liquids present, because essentially you see two layers that are distinguished from each other, usually by a curvature, not towards the top usually, but somewhere closer to the middle. That means essentially that the liquid solute would be insoluble in the solvent, because in that case, we didn't create a homogeneous mixture for a solution. So I always like to go through how to be able to visibly see if you're actually making a solution or not with the two main scenarios that we come across.